New unit is on similar figures. In IM1, you talked about congruent triangles. Everyone remember congruent triangles? Yeah? Remember talking about like side angle side and side 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 and all of that stuff? We're not doing that today, but we will be doing that next week. Okay, so similar figures are going to be slightly different. We kind of started with similar figures in the last unit. And how did we show figures were similar in the last unit? What did we have to do? What? In the last unit, we didn't find angles. What did we find? We looked at a dilation. So more specifically, we looked at what? Scale factor. And we compared all the sides of the figure to see if the scale factors were the same. Right? Okay. So same idea here, but we're going to look at some more information. So figures are similar if they have the same shape. So obviously we're going to compare triangles to triangles and squares to squares, right? That makes the shape the same, but not necessarily the same size. So their size can be different, but the shape has to be the same for us to be able to compare. In IM1, we talked about, or you talked about congruency. Who remembers the symbol for congruent? What's the symbol to represent congruent? Equal sign with the little squiggle. Okay, that shows something's congruent. And if something's congruent, it means it's what? Equal. Any guesses on what the symbol for similar is? That's just the squiggle. So we'll use that squiggle as our symbol for similar to. And what's the symbol to abbreviate an angle? What do we use to abbreviate an angle? Like that? Okay. A blank drawing is an enlarged or reduced drawing that is similar to the actual object or place. Okay, so it could be it's a dilation in the sense that it's probably going to be smaller. What kind of drawing would you create? So like the blueprints of the B building. We have the blueprints of the B building, and then they created the B building from those blueprints. There's another name for like blueprint. Any guesses? Map? Okay. No? Okay. So a scale drawing is an enlarged or reduced drawing that is similar to the actual object or place. So they created a scale drawing of the B building and then took that scale drawing and used a dilation to then create what you see as the B building. Okay. Number 4 is probably the most important thing as we move through this. So in similar triangles, corresponding angles are congruent. Corresponding angles are congruent, and corresponding sides are proportional. So in IM1, when you were dealing with congruent triangles, you had to show that everything was equal, that all the angles were equal, that all the sides were equal, right? We remember doing that, probably not loving it. Here, we're going to show all the angles are equal, and we're going to show all the sides are proportional, so meaning the sides have the same scale factor. Okay? Are we okay with that? All right. To find the missing side lengths, set up and solve a proportion. And this just gives you an example. Put the measurements of the smaller figure on top and the larger figure on bottom. But you can do it vice versa. You just have to be consistent with however you set up your proportions. Okay. Are we okay with definitions? Anyone remember what this statement is called? So triangle ABC is similar to triangle XYZ. Are you familiar with that kind of statement? Yeah, the difference is probably the similar symbol versus the congruent symbol. Anyone remember the name? Nope. Okay. It's known as a similarity statement, so I will use that phrasing a lot. And we can look at similarity statements and determine which pieces are corresponding to other pieces. The location of the letter in one triangle will correspond to that same letter in another triangle. So for instance, angle A would correspond with angle what? X, because A and X are in the same location. What would angle B match with? And C? Awesome. The reason we use a similarity statement versus just looking at the triangles or whatever our figure is because we could rotate the figure. It might not always sit perfectly. So if we use that similarity statement, we know for sure what matches up with what. So AB is going to match with XY. BA is going to match with good. And BC matches with? Perfect. Do you remember doing that in IM1? Yeah. Awesome. Okay, let's do the next one together and then I'll let you try one. Angle D corresponds with angle S. O matches with I. And angle G matches with angle T. What about DO? SI, IT, OG, and ST. Good. So if angle S is 25 degrees, what is the measure of angle D? Why? Okay, so if they're equal to each other, the numbers are going to be equal. Remember this statement up here? All angles that correspond to each other are congruent. So because angle S is 25 degrees, angle D also has to be 25 degrees. So angles are congruent, sides are going to be proportional. I want you with your group to do this last one on that front side. All right. What does angle H correspond with? P. What about angle O? Angle I. And angle T? G. PI matches with HO. IG matches with OT. And GP matches with TH. Is that what you said? Okay. If you can do that, you can answer a couple questions on your next test, which is in about 2.5 weeks. 2.5 weeks. You have a quiz on Friday, probably. This Friday. Because I said. I haven't done it yet. Okay. In the last unit, we were solving for missing side lengths. Remember, we found the scale factor, and then we used that to help us find the side lengths. We're doing the same thing here. So we're not necessarily talking about image versus pre-image. Here we go small to big. You can put the larger figure over the smaller figure. You just have to be consistent. Okay, so if we go small to big, they compared 4 and 8. Does that make sense? Right? BC matches with YZ. Okay. And then they compared 3 and the question mark, so AB and XY. Does that make sense according to the similarity statement? Okay. I'm going to change this question mark to an X just because I'm going to solve. And how would I solve the proportion? Cross multiply. So 4 times X is 4X. 3 times 8 is 24. And when I divide by 4, I get X equals 6. There's not going to be a time. So my expectation is that you are writing out the proportion and you are showing me at least a step in there. Okay? But your calculator is not allowed to do all of the work for you, or I will not give you credit. Did he just ask why? Because I said. I'm in charge. All right. Next one. This one doesn't have a similarity statement that it goes with. The rectangle, we can tell which sides are the longer sides versus the shorter side, right? So they compared 3 and 5 and then x over 2.5. Are we okay with that? Right? 3 to 5 and then x over 2.5. Cross multiply. 3 times 2.5. 7.5? Yeah. So 5x equals 7.5. And when you divide by 5, you get x equals 1.5. Are we okay with that? Okay, you try 1 and 2 in the practice problem part. 1 and 2. Or do you need to do one more with me? Nope, you can try it? Okay. All right, number 1. Someone tell me what their proportion is. And technically, you have a couple options. You just have to make sure you're consistent. So someone who wants to give me their proportion. Go ahead, Josh. 6 over 10 equals 7 over x. Are you okay with that? Someone have a different proportion? No? Everyone use that one? Okay, when you cross multiply, you get 6x equals 70. And when you divide by 6, you got 11.7. Perfect. Look at, we're dealing with decimals. We're so smart. Who can help me with number 2? Who has a proportion for number 2? Go ahead, Savannah. Just tell me what your proportion is. What's your proportion?
4.1 over x equals 3.9 over 4.2.
Okay. So 4.1 over x equals 3.9 over 4.2. I will take that. When you cross multiply, you get 3.9x equals 17.22. And when you divide, you get x equals 4.4. Awesome. Okay, now we have a trapezoid. Same rules apply. Let's look for the 2 sides that actually have numbers, where there's no variables involved. Which 2 sides can we compare that have no variables? The 6 and the 3? Okay, so let's go 3 over 6 equals, and do we want to solve for x or y first? Okay, so 3 over 6 would equal what?
12.
X over 12. Cross multiply, so 6x equals 36. X equals 6. To solve for y, what ratio am I going to use again? The 3 over 6, right? I already have it. Could I use 6 over 12 as my ratio? Could I use 6 over 12 as my ratio? Yeah, I know this x is 6 and I know 12, so if I wanted to, I could do 6 over 12. But I'm going to do 3 over 6 just to stay consistent. So just real quick, 3 over 6 reduces to what? 1/2. 6 over 12 reduces to what? 1/2. So it's going to be the same thing, right? We're going to get the same answer either way. And then what's my second ratio going to be? If I'm solving for y. Y over 4. Good. So when I cross multiply, I get 6y equals 12, which means y equals 2. Okay, so you told me that 6 over 12 was 1/2. 3 over 6 is 1/2. What's 2 over 4? 1/2, which means the scale factor for each of the sides is the same and is 1/2. That's going to be important as we prove things next week. Okay, number 4 is fun. What figure do you see? Do you see 2 triangles? You don't see 2 triangles? Anybody see 2? Couple people? Okay, so y'all see this really big triangle? Do you see this small triangle?
What? Where?
Big triangle, small triangle.
Oh.
Yeah?
Yeah.
Everyone see it? Okay, so let's compare the small triangle to the big triangle. Okay, so let's look at this side length here. So this side length of the small triangle is 16. Agreed? What's the side length of the big triangle? 20. 16 plus 4 is 20, so this whole distance is 20. Are you okay with that? Okay, so 16 over 20. So the small triangle compared to the big triangle. And then we're going to do the small triangle and compare it to the big triangle. So 16 over 20 equals W over 12. Everyone see where that's coming from?
Yes.
We sure? Noah says yes. Anyone else? Yeah? Okay, let's cross multiply. 20W equals 192. And what do you get when you divide by 20? 9.6. If you can set up the proportion, the math part is not hard. If you don't set up the proportion properly, there ain't no way you're getting the right answer. So that's what we have to be careful with. Okay, let's do 5 together, and then you're going to try 6. Now, 5's kind of tricky because things are flipped around. So what two sides would I use for my initial ratio? What two sides match up? 4 over 10? Perfect. And then what are we going to solve for first, J or K? K, okay. And then what would my second ratio be? So I did 4 over 10, and I need to do 6 over K.
Oh, man.
Oh.
Well.
Cross multiply. 4K equals 60. When you divide by 4, what do you get? 15. Okay, I'm going to have to do that again to solve for J. So what's my initial ratio going to be? 4 over 10. And then if I'm going to solve for J, what do I need to use? 3.8 over J. Four J equals 38. And what do you get when you divide by 4? 9.5.
So my proportion is 4 over 7 equals 6 over 6 plus b.
Wait, what?
Okay, so she's absolutely correct. Let's see why. Small triangle to big triangle. So small triangle is 4, big triangle is 7. We should be okay with that, right? Now, the small triangle here is 6. The big triangle is all of this. Well, what did we do up here to get all of it? You add them together. So 6 plus b is 6 plus b. We can't do anything else. No? One more time? One more time. Are we okay with the 4 over 7 part?
Yeah.
Okay. So small triangle is 6, which I think everyone had. The big triangle is all of this. So it's the 6 and the b. So up here, when it was the 16 and the 4, what did we do? We added them together. So we have to add these together. Well, 6 plus b is 6 plus b. There's nothing else you can do there. This problem is going to come up a lot, and this problem is the one that always screws kids up. Because I get 6b, like they want to multiply. So they can do this one where you're adding two numbers, but as soon as I throw a variable in that you have to add, you're like, I don't know what to do. I'm not doing it. Huh? Once it's in a proportion, we should be able to solve though, correct? Okay, so 7 times 6 gives me 42. You need to remember that you are distributing to both of those terms. So 42 equals 24 plus 4b. You would subtract 24 from both sides, giving you 18 equals 4b. And you end up with b equals 4.5. Okay. So if you know yourself and you know you're going to miss this type of problem because it took you a few times or you're still giving me crazy eyes, you should probably make a note to yourself. But really, if you look at these two, they're the exact same thing, except this is a 4 and this is a B, but the process is the same. You're still adding the two pieces together to get the full side length. Are we okay with that? Are you sure? Okay.